Welcome to the AI Mode Visualizer, a free tool designed to help you understand how Google's AI Mode evaluates your content. In the new era of search, Google no longer ranks entire pages, it evaluates passages using vector embeddings. Relevance is now a matter of cosine similarity, not just keyword overlap. The AI Mode Visualizer lets you simulate that process and see how your content aligns with real-world search prompts. Start by entering the URL of a page you want to investigate. This could be a blog post, product page, resource hub, any page you're trying to rank. Next, you can either manually enter up to 10 prompts or generate them automatically from a single master prompt. These prompts represent the types of queries that Google's AI Mode might fan out from a user's original search. When you use the automatic prompt generator, our system uses LLM-style expansion to simulate how a single query becomes a constellation of intent variations, just like AI Mode does behind the scenes. Click Visualize AI Mode Coverage to begin. The tool segments your content into 700-character passage blocks, the same way Google's AI Mode does it behind the scenes. It then calculates the cosine similarity between each block and each prompt. The result is a similarity matrix. Each row is a passage of your content. Each column is a prompt. Each prompt is labeled and numbered for easy reference. If you've generated prompts from a master prompt, you can review them, edit them, or run new variations instantly. The percentages show how well each passage aligns semantically with each prompt. The colors help you spot strengths and weaknesses at a glance. High scores indicate strong semantic alignment. Low scores may signal content gaps or misalignment in vector space, even if the text appears relevant on the surface. This heat map is powered by cosine similarity, a statistical measure that compares how closely each section of your content matches the intent of the keyword phrase using embeddings. To understand this factor, we first need to understand embeddings, the numerical backbone of how modern AI models interpret language. In the search engineer world, it is considered the fourth generation of text classifier technology, with TF-I, DF, keywords, and entities preceding it. Embeddings shot into the spotlight with the groundbreaking 2017 paper, Attention is All You Need. This led to the transformer architecture, now the foundation of today's large language models. Embeddings are vector representations of words, phrases, or sentences. They are the basic building blocks of large language models. Essentially, a piece of content is converted to an array of numbers. That array of numbers defines a point in space. These points live in a high-dimensional space. In Market Brew's case, that means thousands of dimensions, all capturing different semantic meaning and relationships. Here we can see a 3D slice of this high-dimensional space. You can see that similar concepts are grouped closer together. Search engineers can use this to write ranking factors that are more powerful than treating the content like keywords or entities. To get an understanding of how powerful these embeddings are, first let's explore a famous invention called BERT. BERT stands for Bidirectional Encoder Representations from Transformers. It's a deep learning model developed by Google that reads text in both directions, left to right and right to left, to deeply understand context. While BERT works well for many natural language processing tasks, it's not optimized for comparing entire sentences or paragraphs. That's where Sentence BERT comes in. Sentence BERT is a modification of the original BERT model that allows us to generate these powerful embeddings. These sentence embeddings are then compared using cosine similarity to determine how similar the meanings are. Even when the phrasing is different, like "my father plays with me at the park" versus "I play with my dad at the park," the model sees them as highly similar. Now, let's apply this concept to longer pieces of content. Here, we've broken the page into 700-character segments, known as embedding chunks. Each chunk is assigned to a cluster using the embedding output from Sentence BERT. These clusters help us group semantically similar content across a page or even across different pages on your site. This chunk-level analysis powers everything from AI overviews optimization to internal linking strategy in Market Brew. So how does cosine similarity actually work? Cosine similarity measures the angle between two vectors, in our case, the vectorized representations of text. If two vectors point in the same direction, the angle is close to 0, and the cosine is close to 1 or 100%, meaning they are very similar. If the angle is around 90 degrees, the cosine is 0, meaning there's no semantic relationship. And if the vectors point in opposite directions, the cosine is negative, indicating they are dissimilar. In practice, this technique allows us to compare any block of content to a keyword phrase or even to another page and score the semantic similarity. Click any score to drill into that exact passage and see how it compares to the selected prompt inside our AI Overviews visualizer. This takes you to a deeper view, where you can evaluate not just the similarity score, but the actual phrasing and surrounding context. This is how you optimize content mathematically, not just editorially. You'll get embedding-level insights, including the full passage text, the original prompt, and how closely they align in vector space. This lets you identify not just if something is relevant, but why. And that's the level of transparency you need to optimize in an AI-first world. Want to rebuild your SEO strategy for AI mode? Stop guessing. Start modeling.